Back to my channel. Here we are going to be working on the construction of Archimedean spiral, and I have a very special question to solve on this construction of Archimedean spiral. The question that I have says that draw an Archimedean spiral of 1.5 convolutions for the shortest and the greatest radii as 20 millimeters and 90 millimeters respectively. Also, draw a tangent and a normal to the curve at a point 50 millimeters from the pole. Let me take the question again. Draw an Archimedean spiral of 1.5 convolutions for the shortest and the greatest radii as 20 millimeters and 90 millimeters respectively. Also, draw a tangent and a normal to the curve at a point 50 millimeters from the pole. That is the question. The question is a very special one in which we are constructing an Archimedean spiral of 1.5 convolutions with the shortest and greatest radii 20 millimeters and 90 millimeters. So let's start. So the first thing that we are going to do here is to draw a horizontal and the vertical center line. So I'm going to draw a horizontal center line, so this way. Okay, so we have the horizontal center line, and then I'm going to draw a vertical center line, okay, with the set square here. So we draw a vertical center line like this. Okay, all right, so we have the vertical center line drawn. So the next thing that we are going to do is that, as we are told that the shortest radii is 20 millimeters, okay, so this is the pole. So we are going to put O at this point. This is the pole. Okay, then we are going to take a measurement of 20 millimeters away from the pole, so which is the shortest radius. So okay, so here we have where we have the shortest radius from here to here. So I'm going to call this point, I will call it point A. So this is point A here. Then the greatest radius is 90 millimeters. So what we are going to do with that is to take a measurement of 90 millimeters on the ruler. So we take a measurement of 90 millimeters. So from here to here, okay, this is 90 millimeters. I have 90 millimeters here. Then we are going to draw a circle. So we draw a circle of radius 90 millimeters, which is the greatest radius as we are told in the question. So we draw a circle like this. So I believe you can see the circle. Okay, so we have the circle. So this is the circle now. So what we are going to do now is that we are going to label this point as point B. So this is point B here. So here we have B at this point. Okay, so OA and OB. So OA is the shortest radius, while OB is the is the greatest radius. So what we are going to do right now is to divide the circle into 12 equal parts. We are going to divide the circle into 12 equal parts. So I'm going to divide the circle into 12 equal parts with the use of the set square. So I'm going to draw a line from here to here. Okay, then I'm going to draw a line. So I need to manage this. So by breaking it into two, so I will draw a line from here to touch the circle here, and then I will take it up like this. Okay, and draw the line to touch the circle up here. Okay, then I'll be turning the set square this way. Okay, then I will come to the center here and draw a line. So from here I will draw a line to touch the circle here. Then I will be bringing it here like this. Okay, so I bring it to this point, to the center here, or to the pole of the spiral. So I will draw a line, so go in this direction touching the circle. Then I will slide it up like this, and then I will complete it. Okay, we have the circle divided into 12 equal parts. Now, having done that, don't forget that we are asked to produce this spiral 1.5 convolutions, but let's see what we are going to do. So this point is point 0, so this is point 0. Then we are going to number this as 1, so this is 2, so here is 3. Okay, so here we have 4, so this is 5. Okay, then this is 6, so this is 7. Here we have 8. Okay, then this is 9, so here we have 10. Okay, so this is 11. And then, so we can see this point also is what? Is 12. So that we call it 0 or we call it 12. Okay. So now, since we are producing 1.5 convolutions, so what we are going to do now, we have to have 18 points on this circle. So now that we have 12 here, so this point now will now be 13. Okay, so this will be 13. Then here we have what, this will be 14. Okay, so then this is 15. Okay, then we have this point about, this is 16, then this is 17. Okay, and then this is 18. So half of the convolution will make us to have it about to be number to 18. Okay, so this is what we are to do. So then the next thing that we are going to do is that we are going to divide this distance AB into 18 equal parts. We divide this distance AB into 18 equal parts. So I want to make sure that let's close this line. Let's close it. Okay, so let's close this line. All right, so we are going to make 18 equal points on this distance AB. Okay, not OB, but on AB. Okay, so let's divide this distance into 18 equal parts. So that is what I want to do right now. So which I believe you know how to divide a line into a number of equal parts. Okay, so I'm going to be taking 5 millimeters here, 5 millimeters each. So this is 5 millimeters, this is 2. Okay, so here we have this to be 3, so here is 4, this is 5, this is 6, and then this is 7. Here we have this to be 8, this is 9, and this is 10. Okay, then we have 11, then we have 12, then this is 13. Okay, then this is 14. Okay, we have 14 here, then this is 15. Okay, we have 16. Okay, then so I'm adding 2 to it, that is 17, and what, and 18. So we have this. Okay, we are going to join the last point with the end of the line, that is point B. We are joining the last one with the end of the line, that is point B. So we join this point with point B here. Okay, then so we are going to make use of the ruler and the set square to get other points. So I'm going to take the ruler. Okay, so we have the ruler. Okay, so I have the ruler here now. So I will set the set square along this line. As the line is bent like this, I will set the set square along it like this, and then I will shift to the next point, and then I will draw the line. So from here to here to touch this line, then I will move to this point and draw a line again to touch the line AB, then draw from here to touch line AB. Okay, then I will move to this next point and draw a line to touch line AB here. So next one I will draw to touch line ABC. Then next I will also draw from here to touch line AB. Okay, so we go on like that. So drawing the line to touch line AB, because it is line AB that we are dividing into 18 equal parts. So that's what we are doing right now, as we are told that we should construct an Archimedean spiral of 1.5 convolutions. So that's why we divide line AB into 18 equal parts. Okay, all right, so we go on so with this, and as we are moving to the last one. Okay, so we are moving to the end of this work here by dividing line AB into 18 equal parts. All right, so we go on, and last okay, second to the last, and lastly, so we get to the last one. So this is it. All right, so we have 18 equal points on this line, but I'm not going to number because the points are very close to each other, so I'm not going to number, but we have 18 equal points there. Let us count it. This is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. You can see it. So we have 18 points there. So what we are going to do next now is that we are going to be working on how we can make the Archimedean spiral. So we put the pinpoint here at point O here at the pole, and we extend to 1. So we extend to 1, so on the line AB. So this is point 1. So from point 1, we are going to draw an arc to touch line 1. So which is this line. So we draw to touch line 1. Okay, then we extend to 2. We extend to 2 from here, and we draw an arc to touch line 2. Okay, we have this. Then from here we extend to 3 again. So we draw an arc to touch line 3. So touch line 3. Then we extend to 4. We extend to 4. Okay, so we extend to 4, and we draw an arc to touch line 5, or to do touch line 4. And then we extend to 5. We extend to 5. We draw an arc to touch line 5. Okay, then we extend to 6. So we extend to 6. we draw an arc to touch line 6. So this is it, okay? So it touches 6 here, okay? Then we extend to 7. We extend to 7 and we draw an arc to touch line 7. Just take it easy. So to touch line 7, this is line 7 here, okay? Then we go on again. We extend to 8. We extend to 8 and we draw an arc from 8. We draw an arc from 8 to touch line 8. So this is line 8 here, okay? So then we go on again to 9. So go on to 9 and we draw an arc from 9 to touch line 9. So this is line 9 here. So we have this, okay? So then we extend to 10. We extend to 10. So this is 10 and we draw an arc like this to touch line 10. So it touches line 10. It touches it here, okay? So we have this and then we extend to 11. We extend to 11 and we draw an arc to touch line 11. So here we go like this and then here we have line 11. It touches 11 at this point, okay? So now, so then the 12th one, if we draw the 12th one, which is this one, let's draw it. So if we put the pinpoint here, okay, if we put the pinpoint here and we extend to 12, let's extend it to 12. So we extend to 12 and we draw an arc like this, okay? So it goes like this, okay? It will also end here at 12. That is what's going to happen. So the 12th one, make it to be the 12th one that we have here. So it makes it, okay, okay. All right, so the 12th one, so even I don't have to, it's not compulsory I draw that. So this is the 12th one, so it will touch this point. This is where it will stop, okay? So the 12th one makes it one convolution. That is the first convolution, as we are drawing 1.5 convolutions. So 12th one make it one convolution. So we are ending it at this point for the first convolution, for the one convolution, for one complete convolution, it will end here on 12. So let's take note of that, and then so let's take note of the point that we have here. So we have this point for 1, and then we have this point for 2. This point is for 3. This is point 4. This point here is for, okay, we have 5 here. So we have okay, sorry, this is 1. We have 1. This is 2. This is 3. This is 4. This is 5. And then this point here is for 6. And then we have this point for 7. Okay, so this point is for 8. And then we have this point for 9. Okay, so this point is for 10. So this is 11. And then here we have this point here. So this point here is for 12. This is point 12 here. Okay, so when we join this together, we have the first convolution as we are told. Okay, so now let's go for the remaining half convolution. So from this point O here, okay, we extend it to 13. So this is 13 here. We extend to 13 and then we are going to draw an arc. So we have 13 on this line 1. So we draw an arc from here. So touching this line. So this is 13. And then we extend to 14. So we draw an arc. So touching 14 here. So this is the point. And then we extend it to 15. We extend to 15. Okay. So then we draw an arc. So for 15, we draw an arc like this. So it touches 15. So this is where we have 15 here. And then we extend it to 16. So we extend it to 16. So 16, it goes this way. It goes this way. So it touches 16 here, and then 17. We extend it to 17 here, and it goes. Okay, so we extend it to 17, and it goes and touches 17 here. So it touches 17 here. So the remaining 18, it will land here. This is where we have 18 to land here. So that is the half convolution. That is many half convolution. So let's take note of those points. So we have a point here on, this is 13, and this is 14. Okay, this is 15. Okay, this is 15, and then here we have what we have 16. Okay, this is 17, and then this is 18. So we have 1.5 convolution. So what we need to do now is to join the point together to obtain the Archimedean spiral as we are instructed. So we are joining okay, so we are joining these 2 points together. So this point A, so we are joining together with point 1 on line 1 here, and it goes like this. Okay, we have this now. All right, so then we are joining these 2 points together. So joining these 2 points, so we can join these 3 points together and it goes like this. Okay, we have the steady point joined together at once, and then so we move through here, so we can join these steady points, we can join them together like this. Okay, we have this. Okay, then we go on, so we can join this steady point, we can join this steady point, we can join them together like this. Okay, so we join these 3 points together, so we have this. Okay, we are still working on the first convolution. Then we join, so let's join these 2 points, let's join them together like this. So we join these 2 points together, and then here we join these 2 points, we join them together like this, join these 2 points together like this. So we have these 2 points join together like this, so we have this. Okay, then going on, we can join these 2 points, we can join them together. Okay, and then we join these 2 points, we join them together. Okay, like this. Okay, then we also join these 2 points, we join them together. Okay, so we join these 2 points, we join them together like this. Okay, so we have this. So we have completed the first convolution. So the next convolution, the remaining half convolution, start from here. So by joining these 2 points together like this, so we join these 2 points together. Okay, then so we also join these 2 points, so we join them together like this. Okay, then we join these 2 points, we join them together. Okay, and then we go on by joining these 2 points, we join them together like this. Okay, then these 2 points, so we can join them together, and then lastly, so we connect this last one, so this one, we join it together with the last one, which is the 18th one. So looking at what we have here, this is 1.5 convolutions as we are instructed to do that. Now the next thing that we are going to do is for us to draw a tangent to a point 50 millimeters from the pole, to a point 50 millimeters from the pole. So we are going to get that 50 millimeters. So this is what I'm going to do. So I will take my ruler, so set it along this pole, so the set along this pole, and I will just turn it like this. Okay, from that pole, so that 5 is still at the pole, so I want to get that 50. Okay, so looking at this, so this is 50, so I have 50 at this point, so this is 50, so this point is point 50, so I have 50 here, so this is 50 here. Okay, so I have this to be 50 millimeters as we have it there, so that's 50 millimeters. So here I have 50 millimeters here, so I'm going to call this point, I'm going to call it point M. So this is point M here, so here I have M at this point. Okay, so the next thing that I'm going to do is that I need to draw a short perpendicular line to this point over here, a short perpendicular line to this point. So I need to draw that line. But for me to draw that line, I need to do a simple calculation. I'm going to call that line, I'm going to call line ON, so line ON. Okay, so then the calculation that I'm going to do is that I'm going to subtract the shortest radius, which is 20 millimeters, from the greatest radius, which is 90 millimeters. So 90 minus 20, so we have 90 minus 20, so divided, so you are going to divide it by 1.5, so 1.5. Okay, so times 2 pi, so 1.5 times 2 pi. You have to do this calculation because the distance, the shortest line that we are going to take from the guy that we're going to draw from the pole here, must have what? You must get the distance from this calculation. And from what I've done here, so by my calculation, so I have that distance to be 7.43. That distance is 7.43. So it is 7.43. So we have it to be 7.43. So I'm going to, that line will be at a right angle to this point O here, to be at a right angle to point O. So let's see how that can be done. So I need to make use of my protractor. So I'm looking for my protractor. So this is it. So I'm going to set like this. Okay, I'll set like this, and looking at what I have here, okay, I'm going to set like this. So I need that 90 degree line, 90 degree line. So that 90 degree line, I'm looking at how I'm going to set it. Okay, now if I look at this line here, this line is at a right angle to this line, so it's at a right angle to this line. So what I'll just do is that I will take that word, I will just make it 8 millimeters instead of what, instead of 7.43, I'll make it 8 millimeters. So this is 8 millimeters here. So this line is at a right angle to the circle, sorry, to point O or to the pole. So the next thing that I'm going to do, so this is point N now. So here we have N at this point. Okay, so what I'm going to do now is that I'm going to draw a line. So joining this point N with point M, so I will draw a line. So from this point N, and I will draw it to pass through point M, as you can see it here now. So for the normal, all I have to do is to make this line a thick line from here to here. So this is the normal now. So we have this line to be the normal line. So this line, so I'm going to call this point on the line, I will call it L. So this line LM is the normal. Now to now draw a tangent to this curve at point M, so what we have to do is to set the protractor. So we set it on line MN. On line MN, make sure you can see a little part of point M. Okay, so just set like this. So the 90-degree line on the protractor should be on line MN. Then a little part of the curve should be seen here, or the point M